And I couldn't find enough multiple choice questions to adequately do that. So this is a bit of a combo. So there are written questions at the beginning and then multiple choice. The answers to the written are still in the back. So on the written ones, they're a little hard to kind of transfer to your notebook because there's a graph and everything. So I've tried to give enough space on the sheet itself to do the work. So you can do the work for the written ones in the packet, and then the multiple choice, you should really do the work in your notebook. Here we go. Look, extremely important rule for the AT test. Don't let the test writer intimidate you. Like, they're going to find ways to present the problem using wording and pictures that will seem unfamiliar. It's normal. That's their goal, is to get you to be a little bit off balance. So instead of being intimidated, just take whatever they give you and just find one step. That's all you have to do. So they give me a graph, or they give me a formula. Formula is a little unusual because it involves an integral, but no big deal. Integration is just a mathematical operation like addition, so don't be stressed by that. They say find g of -1. So literally I use the same skills I learned several years ago prior to this class. If you have a formula for g and you're supposed to find g of -1, we just plug in the -1. So g of -1 is going to equal the integral from 0 to -1 of f. And they use a different variable here. Instead of x, they use t. But remember, that's just so these two don't match. Basically, this is a function of x. Okay, the t is just a substitute variable. So, question. All right, keep going. First thing I notice is this integral is backwards, 0 to -1. So we talked a few days ago how I can maintain equality by multiplying the integral by -1 and switching the limits. Question, please.
Are you timesing by -1? Would that be like if there was it was 0 like -2, would you still times by -1?
Oh, awesome. Perfect question. 2 points. So yeah, it doesn't matter what the value of the limits are. As soon as I switch them to make this line equal to this line, I have to multiply by -1. If this had been negative already, I would still multiply by -1 and it would switch to positive. So another way to think of it is you basically switch the limits, switch the sign to maintain equality. 2 points. Oh, please.
You just take the top one and put it out.
Say it again.
You just take the top one and put it in front.
No. So what I did is I took the limits and literally switched them. And then to maintain equality, I have to change the sign of the integral.
Oh, okay. So
Yeah.
okay.
So the -1 here has nothing to do with that -1. 2 points.
So on the graph, is that g of x or f of x?
This is f. Is that what you meant?
Yeah, so it's the line f of x.
The line is f of x. So g is some other formula. It's not this graph. It's some other graph.
Oh, then they give you, okay.
Right. And they're just telling you that g and f are related by this graph. But this is the graph of f. 2 points. Right. Cool. Just keep going. Look. Okay. New idea here, but it's really simple idea. We've done a lot of work where we used an integral to find the value of an area. Okay, we're going to do the opposite this time. They're telling me that g of -1 is equal to the integral of f from -1 to 0. So I look over here, start at -1, stop at 0. I'm integrating f. So the integral will be equivalent to the area of the red triangle. So it's just flipping the idea around. We could create an integral to find that area. In this case, we're going to use the area to calculate the integral. So that's just a triangle. So see, 1/2 base times height. So the area here is 1/2 base is 1, the height is 3. So that area is 3/2. Question. Therefore, the value of the integral is 3/2. But it's the area of, it's the integral multiplied by -1, so I get -3/2.
Will they always be shapes to the point where you can do that?
2 points. They will create, the only time they're going to ask you to find the value of an integral using area is if they give you nice square, triangle, rectangle, combinations of triangles and rectangles. I have seen circles or half circles, just pi r squared, no big deal. And I have seen some where they're curvy, but then they just tell you. They're like, oh, this curvy shape has an area of 3. And as you're working the integral, like, oh, I need that. So you just use it.
Okay, so the reason that the 3/2 is negative right there is because it would be positive on the top one, but because we multiplied it by -1. Do you get what I'm saying? That's why it's negative?
So in reality,
Because an area is
you're awesome. Watch this, it's perfect. If we're integrating backwards, you're taking values of f multiplied by dt. But if you're going this way, dt is changing negatively. So this integral's value would come out to be -3/2. Not because area is negative, it's because really you're going this direction and the dt ends up being negative. So they're the same.
But you multiply the second one by -1.
Right, because I turned the limits around, so I'm going this direction now. So the dt is positive. I'm not giving you a really good answer.
Do you do that just to like make it look better for ourselves?
No.
Or is it an actual purpose?
Try this, Hadley. If I did this integral on my calculator, what the calculator would do is it'd plug in 0, it'd find the value of f, which is the height of the rectangle, it'd then multiply by a negative number here, because dt would be negative. So you get a negative value. It does it over and over again, you'd add up a bunch of negative values and the whole thing would be negative. Here, we're starting at -1, plugging in f. So we're getting length, length, length times a positive width. So these all come out positive, but you multiply by the -1, it becomes negative. I'm not really happy with the answer I'm giving you. For now, it's just the math. The area isn't negative, but the value of the integral is negative. So, and I apologize for not a very good answer. If we spend some time after, we can talk a little bit more. So. 2 points. Anybody else? Cool. Next one says find g prime of -1. Let's see. This is the formula for g. I remember that I can never plug in a number until I found the derivative. That's been consistent all year long. Don't plug in the number until you find the derivative. So I need to find the derivative first. Question, Maya?
Just about notation. Do you have to rewrite g -1 equals -3/2, or do they follow that word?
This works fine, because it's this is equal to this is equal to this. But a good point. Hey, in this written question, they're asking for 3 different values. If all you do is write 3 values without any equal sign, you'll get 0 points instead of the 3 that you're eligible for, because they have to know which is which. So, but this is fine. Okay, I need to find the derivative first. So I need to find the derivative of this integral. Okay, you do not have a rule yet. I'm going to tell you the rule. If you'd like, I can write down the rule as well. But I have found that the vast majority of people do better just hearing the rule than like writing it out. It's just harder to make sense of written. So here's the rule, and I can write it if you need me to. To find the derivative of an integral, you're first going to identify the integrand. So the integrand here is f of t. You write it down. So the derivative of this integral is the integrand with the upper limit plugged in. You're taking the integrand, which is f, and you're plugging in the upper limit, which is x. And then you're multiplying by the derivative of that upper limit. Okay, always take your derivatives in terms of input variable. So in this case, we're taking the derivative of g, whose input variable is x. So this has to be over dx. There's more, but questions to that point.
So would they give you a problem where the integral at the top is a different number and you have to plug that in, or they all always have it dx?
It's perfect. I've seen problems where this is 5 and this is x. And I've seen where this is x squared and this is x. We'll show you one today where this is actually a different function, like h of x. So no, they can do whatever.
And you would just do f of 5 over d5 over dx?
Just follow the rule. Just follow the rule. So take the integram, plug in the upper limit.
F of x a constant?
F of x is not a constant. It's this function up here. Again, don't worry about subsequent steps. Just kind of focus on one at a time. Good there? 2 points for Preston and Elijah. Cool. Now you subtract. The rule's easy to memorize because you do the exact same thing with the lower limit. And it kind of looks like we're using the fundamental theorem because we are. Just we didn't have to find the antiderivative because we're taking the derivative anyway, so that kind of, heaven forbid, cancels out a little bit. So we get f of the lower limit multiplied by derivative of that lower limit. Again, crucial that you put dx here, not dt. The input variable is x. The t is just a little temporary variable. Questions? Cleans up really fast because d of 0 over dx is what? Say it out loud. 0. One person, that was good. So what's this derivative? 0. There we go. How about dx over dx? 1. So in this particular problem, g of x, g prime is equal to f. As I said to Elijah, that won't always happen. That just happened on this one. But it does happen a lot. Like they give quite a few questions over the years where it's a simple formula. The result is very simple. But don't fall for the trap when they give something a little more complicated.
What happened to the f of 0? Oh, because it's times by the 0.
Perfect. Yeah, f of 0 itself is 3.
Okay.
But the derivative of 0 is 0. So. Anyone else? Cool. Now we need to plug in. So we take g prime of, they're asking -1. So we need to go find f of -1. Extra credit for the whole room. We paid tallies last time, so we're starting over. So raise your hand if you know f of -1. Just raise your hand. F of -1. Ethan?
0.
How many knew it? 2 points. Wave if you need me to show. So this is the graph of f, and we're looking at x equal -1, so we're right here. And it's the value of f at x equal -1 is 0. Anybody else just wave? Cool. Need to find g double prime. Well, g prime is f. So g double prime will be f prime. F prime means the tangent slope of f. So g double prime of -1 is equal to the tangent slope of f at -1. So I'm looking right here, trying to find this slope. I just look at the line and say that line goes up, so I know this value is positive. Just raise your hand, we'll pay extra credit. How much does that line rise? We're trying to find the slope of f right there. So just, how much does it rise? I'll pay everybody. What's the rise of that line from here to here? It's the rise of the line, the rise of the line from there to there. Let's go, Tristan. Somebody soft? 2 point. Say that out loud, please. What's the run? 2. If you stop there, you get full credit, but you can also write 3. So. Just wave at me if you want me to go through that again. So, talk with me, it'll stick better. So, what does f prime of 1, negative 1 mean? So what does f prime mean? About. And what's another meaning of the word derivative? Tangent slope. All good. Now we go here to f. Here's x equal negative 1. I want the slope right there. But being a straight line, the slope there is the same as that slope. You see it now? 2 points. Please,
Will they make us find the slope of a curved line?
They will not. Not without additional information. We saw some problems earlier this year where they gave a graph, had a curve, and then drawn on the curve were a couple of tangents. And so as you worked through the problem, you got to the spot in the problem, like, oh, I need this tangent slope so I can use this line. But they won't actually visually determine a curve's tangent slope. Please, Ellie.
So for the g prime, when you put in the f of x, do you always just put like the input variable of like the g of x?
Say one more time, Ellie.
So when you do the g prime, when you do f of x, do you just put in the variable of like what's being the input variable, right?
Like here it said find g prime of negative 1, is that what you mean?
Yeah, so instead of doing like f of t, you would put f of x because it's g of x, right?
Oh, let me say that back to you. So really, this is a graph of f of x. The t is just a temporary variable. They could have put z or q or u or whatever. So it really has nothing to do with the problem at all. That didn't really answer your question, though.
Well, could you put t then? Like if you were to write it all in like the way of
No, you should really use x.
Okay.
Yeah, it really is a function of x.
Okay.
2 points. Questions? Please.
Can you write out like the general rule for how?
Uh-huh. So the rule would look like this if I were to write it down. Some textbooks actually refer to this as the second fundamental theorem of calculus.
Okay.
I just call it the rule for finding the derivative of an integral, because that's what it's doing.
Yeah.
So to me, that's easier. So the derivative of any integral. So the integral has a bottom limit and a top limit. And as I was saying to Elijah, the bottom and top limits could be anything. So I'm going to call the bottom limit some function of g, and the top limit some function called h. And the integrand could be anything, but we can't have x and x here, so we put a t there, like that. Everyone okay? So now you take, now please, all eyes look here, everybody looking. Please don't forget, if I'm just finding the integral, I have to find the antiderivative first. If I'm just finding the integral. So I would never, if I'm finding the integral, I'd never write f. I'd have to find the antiderivative. But because I'm taking the derivative of that integral, those two things literally do cancel a bit. So here you just write f, you plug in the upper limit, and then you take the derivative of that upper limit. I wrote that wrong, sorry, hold on. Subtract the same thing with the lower limit. In fact, maybe it's better to write it like this, hold on. Looks a little more like what we actually do. Let's use this notation. Sorry about that. So this would be d of h of x over dx. Same thing for the lower limit. So that's the general formula for finding the derivative of any integral. Please.
Never mind.
2 points. Anybody else? 2 points. Oh yeah, 2 points.
We need a
Everybody mark down 3, 4, 5, whatever. Okay, cool. Yeah, mark down 5. It's good, Dave. Everybody good here? Cool. Okay, go to number 8 in your notebook. Go to number 8. So this thing you'll need to do in your notebook. There's not room in the packet. So number 8. We're trying to find a limit. Okay, you remember from the limit flashcard. First thing, I check to see if the limit is x approaching, in this case h. Is h approaching infinity? No. No is the correct answer. If h were approaching infinity, I would have to compare terms that are adding. Skip that. Second item on the limit flashcard is, can I factor and divide? No. 2 points for no again. Okay? So now you have a new method today. First time you've ever heard about it. It's named after the French mathematician who invented the rule. Okay? What's that?
Sure, it's not one of your
2 points. In this case, not this time. So that's awesome. 2 more. Put down 4. That was really good. Yeah. So the guy's name was L'Hôpital. I'm not good at speaking with a French accent, but you know. Okay. Here's what his rule says. Before you can use the rule, you must do a test to verify that the rule actually works. Okay? So here's how you test. You plug in the limiting variable value. The limiting value which in this case is h approaching 0. So the limiting value is 0. If the limiting value were 5, we'd plug in 5. You just plug in the limiting value. Remember, when you're finding a limit, you don't really want to ever plug in the limiting value, but with L'Hôpital's test, that's what you do. So do it with me here. So put a 0 here. Oh, please, why?
So we're only plugging in 0 because the 0 is the limit. So if there's a different limit, we would plug in that number.
Perfect. If this were h approaching 3, we'd plug in 3. Be careful. You're going to encounter some problems where there are x and t in the problem. Don't plug the value into both, just whatever specified, in this case h.
And this is because we can't factor or do anything else.
Perfect. Yeah, you're trying to find the limit. Your first choice really should be the tools we've already practiced. This is just a new tool. So. And the reason I didn't give you this tool earlier is you have to be good at derivatives to use this. And so I kind of wait until we're comfortable with derivatives and then use this. So, let's see. Put a 0 here. I want everyone to see it for themselves. So look at the numerator. Raise your hand and you can tell me if I put in a 0 for h, don't overthink it, what will the value of the numerator become? Raise your hand when you can see it. So you're plugging in 0 for h. Raise your hand when you can tell me what will the value of the numerator become when you plug in 0 for h. We're testing the numerator here, so we've got 8, 1/2, plus 0. Hands, you can see it. Don't overthink it. What do you get, Drew?
0.
How many votes? 0? 2 points. We plug in the limiting value in the denominator. That obviously is 0. That's a really bad infinity. Okay, look, 1 second, Dave. Hey, when you do the test, if the result is either 0 over 0 or infinity over infinity, and it can be positive, minus, whatever, that doesn't matter, then the result passes. That means you can use the test. So this is what you want. You want to get 0 over 0 or infinity over infinity. Okay.
How's the numerators go?
So they just become the same thing. Because you got,
Oh.
yeah, no worries. 2 points.
What's
Please.
the like plus and minus in front of you?
That just means you might do the test. You might end up with negative infinity divided by positive infinity.
Okay.
That's still a successful test.
Oh, it can be like a small.
Yeah, any combination. So you might end up with negative infinity divided by negative infinity. That's good. Maybe positive infinity divided by negative infinity. That's fine.
Can you explain that? Second part again?
Right here.
Yeah.
So what you're doing with the test is you plug in the limiting value. If the result happens to be 5, the test fails and you can't use L'Hopital's rule. If the result happens to be 0, the test fails. You can't use L'Hopital's rule. But if you get 0 divided by 0 or infinity divided by infinity, then the test is successful and we can use the rule. So before I can show you the rule, you must do the test. Please.
What if the test fails?
If the test fails, then you probably could have factored and you just didn't notice. And then you go back, factor, and divide, and then you can solve the limit that way. That's most common, to be honest. Or you can use the Christian Hunt method and say, I guess I have no idea how to solve this, so D looks like a good answer. So, seriously.
Well, yeah, I believe it.
But yeah, you're right. So basically it just means you should have used a different method. So. Look, one of the answers here is the limit does not exist. Okay. In our class, that's never the answer because you can't find the answer, okay? This is only the answer if the two left and right limits aren't the same, okay? So don't be marking this just because you're like, I don't know. So, that's likely not the answer. So, okay, once the test is successful, we now apply the rule. Here's the rule. The rule states that the limit, as h approaches any value, of one function divided by another is exactly the same as the limit, as h approaches that same value, of the derivative of the top divided by the derivative of the bottom. That's the rule. Question?
Want to explain that again?
So we start with a function where we're taking the limit of one thing divided by another. So I can see that. The rule says I can't find this limit. Maybe I can find this limit instead. And they'll be the same. So I'm going to create a new limit problem. So this is the rule. What I do with that rule is I create a new limit problem.
A just represents
Any number.
How do you know what you're saying? Like, to get rid of it?
Hold on a second. 2 for my second. Couldn't hear you.
How do you know that the derivative of f will be the same as the previous one?
Oh, awesome. 2 points. The derivative of f is not going to be the same as f. What L'Hopital discovered is if the limit passes this test, these are different limit problems, but they have the same limit result. No kidding, I agree. So we're going to make a new limit problem that's easier to solve, and the answer to our new problem is the same as the answer to the original. That's L'Hopital's discovery.
So why weren't we able to find the original one without taking that?
Because it's like if we had a calculator, we could find it. Because we could plug in something really, 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 really close to 0 and just punch it out and it'd tell us. But mentally, that's really, really difficult because these numbers are so hard to deal with.
So it just makes it easier to do that.
Yeah, L'Hopital's rule has no purpose if you have a calculator. It was invented, of course, hundreds and hundreds of years before calculators were discovered. Which,
Freaking kidding me?
freaking kidding me is the right word to respond to that. Well, he's now, he earned lots and lots of money and became very famous. Now we're Christian. Here we go. So to create a new limit problem, we take the derivative of the top. So we need to find f prime. So f prime is equal to the derivative of f, which is the derivative of that top function, which was 8 multiplied by 1/2 plus h to the 8th power. Subtract 8 multiplied by 1/2 to the 8th power. So I'm just taking the derivative of the top. It's not the quotient rule. It's much easier than that. Just the derivative of the top.
I was itching my head. Trust me, I don't know this.
2 points for itching. Okay, we good? Look, this part of the derivative is really easy. It's two things being added. This is a constant. So this derivative is 0. So when you have the derivative of two things being added, you take the derivative separately. This all by itself would have a derivative of 0 because it's just a constant value.
Isn't there an H?
There's an h here, but not here. This should be an h, sorry, not an x. I'm not sure I understood your question, Avery.
So it's just that we didn't not totally a constant because there's some H in there.
So this isn't a constant. This would vary depending on the value of h. This is not changing.
Yeah,
So that's 0.
okay.
2 points for Avery. Bring down the h, you get 64. There's 1/2 plus h. This would become to the 7th power, multiplied by the derivative of the 1/2 plus h. We need to talk through that. Okay, it goes pretty fast. Raise your hand, I'll pay. What's this? Hands up, come on. Raise your hand, what's this? Remember, you can take the derivative separately because they're being added. So you just need to find the derivative of 1/2 and then the derivative of h. Looking up, looking up. Boston. 1. Just 1. The derivative of 1/2 is 0. dh over dh is 1. So now we just have this. How many had it? 2 points. Question? Please.
Is that the power rule or is this something?
Power rule.
So why didn't you do the power rule on the next one?
Over here?
Is that, no, the parentheses 1/2 plus h, is that just?
You're just forgetting the power rule.
Okay.
The power rule says h is just a constant. It tags along.
Yeah.
So we got something to a number.
So if the number's 1, it's just pointless
If the number here is 1,
yeah.
then you wouldn't use the power
Okay,
rule.
yeah.
But what you're thinking is incorrect. Like, well, I'm not sure. So you bring down the 8. So you have something to the new 8 minus 1.
Yeah.
This is always just the derivative of something. So there's never a power here.
Yeah, I was just
Oh,
thinking
okay.
it was to the power of 1, so you could technically use
I'll
that,
do it
but
again.
just be
Gotcha.
easier
That's
to-
true. Yeah. Point. Anyone else? Cool. Okay, that's the first part of L'Hopital's rule. Second part is we've got to find the g prime. G prime is the derivative of the bottom with respect to h. That'll just be dh over dh. So we get g prime is just dh over dh, which is just 1.
Do you find both of the derivatives separately and plug them back?
Separately. The rule says, hey, you're starting with the derivative of a ratio. You create a new, sorry, not derivative, limit of a ratio, you create a new limit. So here's our new limit problem. We're going to find the limit as h approaches 0 of f prime divided by g prime, which is the same thing as the limit as h approaches 0 of 64 1/2 plus h to the 7th power, all divided by 1. Question, please.
How is G prime pH over pH?
So you start with recognizing that this is the limit of one function divided by another. Does that make sense? And L'Hopital's rule says as long as the test passes, this limit will equal a different limit problem. These should have been h's. Like that. So I take the derivative of this. But I have to take it in terms of the limiting variable, so it has to be dh over dh. I did write this incorrectly. This should have been h right here. Should be h right here.
You get postdocs on the test.
This should be h. You don't have to show all the stuff that I'm showing because I'm illustrating the rule. If you made that error, I think they'd be forgiving. This should have been h.
Mrs. Smith?
Yeah.
For fourth term, are we learning anything new, or are we just doing practice tests? Things like that?
So it's actually a lot of new learning. It's just not really learning new concepts. It's like learning how to use what you already know to solve problems. See what I'm saying? So it's like learning. It's like you know, at the end of term 3 or whatever, or close to that, you end up with this toolbox where you've got all these tools, all these different concepts that you've learned, but then you have to use how to apply them to lots of different situations. So it's not review. It won't feel like that at all. It'll feel like you're really learning a lot, just different style in a sense. That makes sense? Cool. It really is. Eyes over here. Okay. I guarantee, like, if you put effort into it, term 4 is by far the most rewarding. Because that's the best part. It like gives you a taste of what it's like to be in a profession, where you're not every day learning something new, practice, learn new practice. It's more like, hey, I've got all these tools. How do I apply them? How do I use it to solve something? That's what it's going to feel like. It really is a really good taste of being in a profession. Term 4 is the best. I promise. It's just it's an amazing feeling. So, fix this. I may have told you this before, but I thought it was such a good comment from a student. She took the class. She did great. Got a 5 on the AP test. She came back like 2 or 3 years later. She saw this on the board. She came in to just say hi, and she's like, to be honest, she says, I don't miss learning all that, because she remembers how much work it took. And it's a lot of work. But then she said, but you know what? I also have to be honest. I miss knowing it, because it was an amazing feeling to have that knowledge and be able to apply it, like over and over again in lots of different ways. That's what we do in term 4. So probably starting in term 3, to be honest. So. Because I'm so anxious to get to the best part of the year. So.
Is this all the stuff we're going to be testing on this for term 3 or term 4?
So there's no more tests for term 3. I told you when we took the last one, it would be the only test for term 3. Part of that's because I don't like to have a test close to the end. That puts more pressure than I'd like on you to get the retake done and everything. So we won't have that. So your grade is, we might have some quizzes or something to just kind of make sure you've learned this, but we won't have another test for term 3. So. So this is H. Okay. Back here. One more fix. Sorry for the delay. Okay, cool. So now we just need to find this new limit problem. But we have created a rather simple limit problem. Because remember, the last thing you always do a limit problem is just check close to h, not exactly, but close. So if h is close to 0, there's no doubt this is close to 1/2. You need me to do that again. So 1/2 to the 7th power, break out my calculator. 1/2 squared would be 1/4, cubed would be 8, 16, 32, 4, 128, done.
I knew
It's
that.
like that game 2048. You
Yeah.
have to do it in your head.
Yeah.
Yes.
Remember, multiplying by 1 over is the same as dividing. So I need to find the limit. So I need h to be not equal 0, but close to 0. So I plug in close to 0, and I think, okay, 1/2 plus close to 0 is going to be really close to 1/2 to the 7th power. That's why I just count it out. 2 points for Hayden. That's it. That's L'Hopital's rule. What's that? We're finding the limit as h approaches 0. So we're trying to figure out what's the value of this function when h is really close to 0. We figured it out. Pretty good? Please.
I have a question. So why didn't you switch out the h's for f prime of x?
Oh, that was a mistake. Thank you.
6 points.
2 points for that.
Thank you.
One ticket.
Anybody out? Awesome. Next one.
I have a question.
Oh, please.
So is the limit, like the h approaching 0, is that going to stay a constant throughout the whole problem?
Yes.
Will that ever change?
No, not for our work. Because you're starting with the limit as h approaches 0, you end up with the same limit as h approaches 0, just a different thing that you're finding the limit of. That's L'Hopital's rule. Okay, please write, actually go to your notebook and write down number 10. Go to your notebook, write down number 10. Allison's looking forward to the video tonight. A little sleepy. Okay. It's a limit problem, so I first check and notice that h is not approaching infinity. So I'm going to use that method. There's no way to factor, so I skip that method. Third choice, L'Hopital's rule. So I take the derivative of the numerator. Remember, with L'Hopital's rule, it's d over d of the limiting value variable. So it's h is our limiting variable, so this is dh. 1 second. That's x to the 5th.
Still dx on the end.
The x that's inside is just a temporary variable. So the true variable in this case is h. Okay.
What happens when this rule doesn't work?
If you try the test and the test fails, that means you probably should have factored. Like you just didn't notice you actually could factor. So you go back, try again. Elijah?
So I kind of noticed on the homework, and I guess like it applies to this problem as well, correct me if I'm wrong. When you take the integral of something, that same number, so like from 1 to 1, doesn't that just equal 0? Because you're not moving anywhere.
It's perfect. So I'm taking the derivative of the numerator and oh, wait a minute, I forgot to do the test. Thank you. Let's do the test first.
That would be so nice.
Yeah, I wish you could do that. On your paper. You can just do it off to the side there. So we got to do the test. So it's what Elijah's noticing. You plug in 0. So you've got the integral from 1 to 1 plus 0. Square root x squared to the 5th plus 8 dx. When you integrate from 1 to 1, the result is 0 because you're not going anywhere. You're starting and stopping in exactly the same spot. There's nothing to integrate. So that's 0. If I plug in 0 on the bottom, the test is successful. Okay. Assume that is an expression of positivity. Oh, I can't draw the hands, but okay. We good? For Isaac.
Yes.
Okay, so you create a new limit problem by taking the derivative. It's the derivative of an integral. So write down the integrand. Plug in the upper limit. Multiply by the derivative of the upper limit. Because the limiting variable is h, this is dh. Question?
You do that like again.
So the good part about the rule is you do it all again. Two compressing is perfect.
I totally roasted my account.
Sorry. You plug in the lower limit. So 1 to the 5th. Derivative of the lower limit. So, question? Wave if you want me to do it again. I really don't mind. It was just convenient. That was the same. Yeah, right. Yeah. Cool. This one's quick. Look, what's d1 over dh? 0. 0 times whatever, that's 0. This one here, remember, they're separate. You can do them separately because they're adding. So derivative of 1 would be 0. dh over dh is 1. This is all 1. So we just end up with square root 1 plus h to the 5th plus 8. Questions?
Wait, so then you would take that and you would find the bottom of it and then you would
Make a new limit problem. So the bottom is just h, so we're going to go dh over dh. That's 1. Now we can create our new limit problem. So L'Hopital's rule says the limit of f divided by g is perfectly equal to the limit of f prime divided by g prime, which is equal to, in our case, the limit, as h approaches 0, of square root 1 plus h to the 5th power plus 8, all divided by 1. You need me to repeat any of that? Wave at me. Now we solve the limit problem. So, if h is really, really close to 0, this one's easy now. 1 plus really, really close to 0 is 1. 1 to the 5th is 1. Plus 8 is 9. Square root 3 is square root 9 is 2. Don't leave. We got one more. Stay here. Please.
So the second after the minus, is that equal 1? Or is that equal 0?
Sig and Bryn.
There.
Right here?
Yeah.
So what's this equal to?
0.
Times that would be.
So where did you get the 1 at the bottom?
Oh, remember, the rule says the limit of one function divided by another is equal to the limit of the derivative of the top divided by derivative of the
Oh,
bottom.
and the derivative of h over
Bottom was just
g of
h.
h. Okay.
Okay? Look up. Okay, because it's Monday, we are a little short on time. But in first period, I was able to get through another example. So if you have trouble in the homework with number 9, just go to the video and you can just scroll through and find where I'm starting to talk about number 9. It's not harder, it's just has a couple of different twists to it. But that's in the video if that helps. Sorry, that made no sense. Everybody give yourself a full 10 points. That made no sense. The video is this group. I'm like referring to something that is not in the video. That makes no sense. Here's number 2. We'll just talk through it. Look. Save a little time, I'll just talk through it. I'm finding this limit, right? So I test first. So I put in h equals 0. This becomes the natural log of 1. Say it out loud. What's the natural log of 1? 0. If I plug in 0 for h on the bottom, you get what we want. 0 divided by 0. Test was successful. Okay. The first thing I had to do, though, is I had to recognize that this is really the limit of one thing divided by another. Because I had to notice that multiplying by 1 over h is the same as dividing by h. To use L'Hopital's rule, you must have one function divided by another. I didn't need to repeat that.
Yes.
To use L'Hopital's rule, you must have, like we showed here, the rule states, it's right here, look. You've got to have the limit of one function divided by another function. So back here on number 9, before I could do anything, I had to rewrite this as one function divided by another. Then I do the test. The test is successful, so I need to take 2 derivatives. The derivative of the top. The derivative of the natural log of something is 1 over the something, multiplied by the derivative of that something. Okay? Don't use the quotient rule here, because dividing by 2 is the same as multiplying by a half. Just pull out the half. The derivative of 2 plus h is just 1. So that whole derivative is just 1/2. So that's right here. Okay? 1 over something multiplied by the reciprocal. 2's divide out, you get this. So this is the derivative of the numerator. Stay with me. The derivative of the denominator would have just been 1. So the limit now, the new limit problem is just this. But as h gets close to 0, that just gets close to 1/2. Good work. See ya.
Alright, can you explain how you change the problem?